try to solve as many problems as possible. Okay, so but let us start from question number 1, exercise 15.1. It is 15th chapter, and 15.1 is the name of exercise. So the first part says probability of an event E. Okay, probability of an event E, and then plus probability of an event not E. Means in a way it's denoted by like this. If we add both of them, it will be equal to 1 actually. Okay, either this event will occur or not occur. So if we add, if it occurs, then yeah, for example, getting head is 1 by 2, not getting head is also 1 by 2. So together it will be 1. And the same, this is for the coin. Let us take for the dice. What is probability of getting 3? Okay, probability of getting 3 plus probability of not getting 3. Okay, so probability of getting 3 is 1 by 2 or maybe 3 by 6 or something. And then probability of not getting 3 is also 1 by 2. Or you can also write 3 by 6 here and 3 by 6. No, 1 by 6. Sorry. I said little wrong here. Probability of getting 3 is actually 1 by 6. And then probability of not getting 3 is, it means either we get 1 or 2 or 4 or 5 or 6 out of possible 6 events, isn't it? So it means probability is 5 by 6. Okay, so if we add 1 by 6 and 5 by 6, again we get 1, isn't it? So these problems are very nice to just clarify your concepts. Let us take the second one, what it says. The probability of an event that cannot happen is, okay, the probability of an event, some event which cannot happen, is 0. It's very, very simple. It's 0. Such an event is called, okay, such an event is called impossible, means there is no possibility of happening. So such an event is called impossible. The third question, the probability of an event that is certain to happen is 1. The probability of event which is certain to happen means there is no other go, it will happen, then its probability is 1. And such an event is called what it is called, such an event is called certain, means it is 100% certain. Let us move to question number 4 of exercise 15.1. Which of the following cannot be the probability of an event? Okay, so, and then there are 3 choices. One is 2 by 3, another is minus 1.5, and then 15%, and then 0.7. So which could not be a probability? So we already saw that any probability should lie between 0 and 1. And which of these options are lying outside 0 and 1? this one, because it is negative. Probability cannot be negative. So this is the answer. No probability could be in minus. So minus 1.5 is not possible. Let us take maybe question number 8. Let us take question number 8. A bag contains 3 red balls and 5 black balls. Okay, so for such kind of questions, it's always better to make some symbols. So let us think that this is a bag. A bag contains 3 red balls. Okay, 3 red balls and 5 black balls. Okay, a ball is drawn at random from the bag, means without looking at it. We just, all the shapes of the balls are same, so we don't know what ball we are drawing. Okay, so we will uh, a bag is drawn at random. What is the probability that the ball drawn is red? Okay, so the first thing we need to know, what is the probability that the ball is red. For this, to what is the, how many red balls are there? 3. And how many total number of balls are there? 3 plus 5. So 3 favorable outcome out of all possible outcomes. So the probability of getting red is 3/8. And then it is asking us to calculate the probability of drawing a ball out of it which is not red. Okay, so in a way we can denote it like this. Probability of not having a red ball is 1 minus 3/8. That is 5/8. Okay, so that is the answer. There are lots of similar questions, so I will try to take up most difficult ones. All other questions you can solve it by yourself. And then if there is anything which you want to ask, please put that in comment. I will make a video of it for any specific comment. I will just read all of your comments and then give solution to those questions which you want to see solution for, which you want to see how to think about it, but I have not given here. So please comment giving the exercise name and chapter and question number. Okay, so let us take question number 11. I will just read it out. Gopi buys a fish from a shop for his aquarium. Okay, the shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. Okay, suppose this is a aquarium and it contains 5 male fish and 8 female fish. Okay, and a gopi wants to buy a fish, means one fish. What is the probability that if the shopkeeper draws one fish at random, what is the probability that the fish taken out is a male fish? So all the possibilities here are 13. Okay, so the possibility of it being a male fish, how many male fishes are there? 5 out of all possible 13. So 5/13 is the probability of drawing a male fish. Now let us take question number 16, for example. Okay, I will read it out. 12 defective pens are accidentally mixed with 132 good ones. Okay, so there are two kind of pens. 12, we will say defective. Okay, defective pens are mixed with defective means we cannot write with it, that or it's broken. And then there are 132 good ones, good pens. Okay, so both of them look exactly the same and they are totally mixed with each other. It is not possible to just look at a pen and tell whether or not it is defective. Okay, one pen is taken out at random from this lot. Okay, one pen is taken, only one pen. What is the probability that the pen taken out is a good one? Okay, so when we take one pen, out of how many possible outcomes we are drawing one pen or possible pens, we are actually, there are 132 good and 12 defective. So what is the total number of pens? Total number of pens are 144. So this is all possible outcome. Out of that, we just take one pen. So probability of getting a good pen there are 132 good pens, and then how many pens are there in total? 144. So this is the probability that the pen is good. Okay, and by just doing some calculation, you will very well find out that it's equal to 11 by 12. Okay, so that is the solution for question number 16 of exercise 15.1. Let us take question number 20. Suppose you drop a die at random on a rectangular region shown in figure 15.6. Again, this is a kind of table or die. Its length is 3 meter and width is 2 meter. It's a typical table or rectangular kind of surface. Okay, what is the probability? And there is one area which is not a hole, but it's an area of diameter 1 meter. Diameter 1 meter. So when, if we just put drop a die at random on this rectangular region, what is the probability that that die will land somewhere here? And when we are telling that, okay, we will just put, and then, but the die can also fall here, isn't it? Die can fall anywhere on this table. So here, the thing is that we are, one thing is very important. We are dropping the die at random, means we are not looking whether it is um, it is going in this area or not, but we just want to find the probability that it will lie within this area. Okay, so this is what we want. So for that, we need to consider two things. Probability here depends upon the area also. Okay, so the probability, the overall outcome could be represented by the bigger area, that is the rectangular area, which is 6 meter square. Okay, and then out of this 6 meter square, there is one area of circle, which is how much? Area of the circle, where we want to know whether die has fallen or not. Diameter is given as 1 meter, isn't it? So you know that pi times diameter is d by 2 whole square. that is area of the circle. So let us take it 22 by 7 as the value of pi, and then 1 by 2 square, that is 22 divided by 4, so 28 meter squared. So this is the area. So the probability that when the die is dropped, it will lie on the area, is will be actually equal to, the ratio of the circular area divided by the overall area, that is 22 divided by 28 divided by 6 by 1. Okay, so then it gives us 11 and then 3. So it means, yeah, you can just multiply it. 28 into 3, so 284. So this is the probability that when a die is dropped at random, it will fall within this circle. Okay, so 11 by 84 is the answer.